Welcome on this session on designing for lifetime value, where we're taking a slightly more long-term look on electrolysis systems, and we look at it from an operations and maintenance perspective. We're trying to design electrolysis systems in challenging economic conditions. Few of us are making double-digit profits, and we make trade-offs now, and I just want to give a few tips and tricks to make sure that we don't regret the trade-offs we make today over the entire operational life of the project. And when we're designing systems for the future, it's always interesting to look at the past. And let's go back around, let's say, 2,000 years. And behind me, you see the Pont de Gare, which is a Roman aqueduct close to Avignon. For those who haven't booked their holiday destination yet, it's a very nice place, good foods, nice nature. And it's still there, on the one hand, because it was built to last. So the Romans took a really long-term view on what they built in terms of infrastructure. But what is more often forgotten is that it was designed to be maintained. These systems were not just bridges. This was part of a 50-kilometer network of tunnels, of canals, of bridges to supply the city of Nîmes with water. These systems had access points for regular inspections. Some of them had silt traps to cover the dirt, the sticks that were floating in the water, very similar to the filters that we're designing today. Some of them had bypass systems, allowing to do maintenance on one section while you could keep the other one in operation. And a lot of cities had redundant aqueducts because they understood it's a critical resource and we need to keep it in operations. The city of Rome had 9 aqueducts, and there is a book called The Aqueducts of Rome, and there's the author Sextus Julius Frontinus, and he dedicated an entire chapter of the aqueducts on maintenance because the maintenance was such an important part. And if I can summarize the main lesson of that book and the chapter on maintenance, it is take a long-term view on what you're doing. And they also did that in terms of contracting. The Romans typically contracted out maintenance over the medium term, so they didn't take a short-term contract. It was typically a term of 5 years. The contractor who won the contract was responsible to have people readily available for preventive maintenance, but also for corrective maintenance. The contractor had to have skin in the game. He needed to give guarantees, and sometimes he had to put up his house as collateral in case the maintenance didn't work out. In case the maintenance broke, then the Romans would confiscate the house and finance the repairs with that. So the 3 lessons of the Romans are: think long term. Thinking long term is not sufficient, so also design for maintenance. And even if you design for maintenance, make sure that you actually have a contractor that has skin in the game so that the repairs and the maintenance is done qualitatively. So let's take those lessons and apply it to electrolysis systems. Thinking long term, we typically do it with the LCOH formula. And we all know it, we all use it. We take the CapEx, the electricity, the OpEx, and the hydrogen produced, we levelize it, and we make design choices based on that. And we do it typically quite well for example, technology selection. Pressurized alkaline versus PUN. We put it in the formula, and we take the right decisions. The main problem is in the details. If we make small decisions, they might have an impact on CapEx or OpEx, but we don't take the global picture into account. A major trend, for example, is containerization today. Everybody is moving to a containerized system. This saves on CapEx, it saves on delivery time in the delivery of the project, and it's better for the EHS of the project delivery on site. Very important. The main problem with containerization is that you cram a lot of equipment in a very small space, making it more difficult for maintenance. So if you containerize in a way that's not smart, and the safety critical devices or equipment that needs frequent maintenance is not accessible, you're basically going to have an impact on the other factors as well. Imagine that I containerize in a bad way and I have a breakdown, the repair will be more difficult, so the OpEx increases. Because the repair is more difficult, it will most likely take longer as well, meaning that the hydrogen produced goes down. Because it's more difficult, I might defer maintenance and run my system in a degraded mode, and thus my electricity costs go. So by trying to lower the CapEx and containerize, I might have increased the LCOH if I didn't do it in a smart way. At Rely, we do containerization, but we do think about these elements. So if you think long-term, think about these elements. When you think long-term, you need to know what drives the LCOH of your project. The previous presenter said every project is unique. So make sure that when you do your project, you run sensitivities. Check what is the major impact on your LCOH. And when you do that, typically you find that it's not the electricity price, which is the biggest part of the LCOH. It's not the CapEx, and it's certainly not the OpEx, but it's actually the availability. And availability of projects are typically not optimized enough, in my opinion, and people don't take enough care of that in the design phase. How do you make sure that a contractor takes care in the design phase because of that? Put it into euros, put it into dollars, so they know what they're dealing with. If we take two 100 megawatt projects of similar CapEx, similar efficiency, and similar OpEx, but one has a 1% availability more than the other one, it basically means that that project produces 130 tons of hydrogen per year extra. That translates in an additional revenue per year of around 800,000 euros. So if I have a 1% better availability, I could spend 800,000 euros a year more. If you want to turn it into a CapEx equivalent, basically you have to levelize that, and that comes down to around 8.5 million euros. So if I optimize for maintenance, and I can gain 1% of availability for a cost of less than 8.5 million euros on a 100 megawatt system, it's basically worth it. So think about that. Also make sure that the people who are doing the designs understand these trade-offs. What can be gained by lowering OpEx, increasing CapEx, or improving availability? At Rely, of course, we think about that. We're a one-stop shop. So we're involved from the pre-FEED, FEED, EPC, and we have operations and maintenance solutions. So when we are an operation and maintenance provider for your project, we can't turn around and say, look, the FEED contractor didn't think about it because we were already involved in the FEED and in the detailed design of the EPC. So lesson one for today, if you think long term, make sure that the people doing the design and doing the work know what's at stake in terms of euro numbers. Second lessons of the Romans, design for maintenance. We're optimizing CapEx, we're driving it down. CapEx is king because that's what we can control in a project. Electricity price, it's much more difficult. So think about access and layout. I talked about containerization. Think about where your safety critical devices are, where you have to do the frequent maintenance to make sure that it's not too difficult. Think about modularity. We all work in modular systems, electrolysis, separation units, PDUs, but also think about the sparing philosophy. Have similar spares across the different systems so that you have a lower OpEx accordingly. Think about what maintenance needs to be done frequently and check if you can do it online. Bypass valves and a few piping cost nothing compared to gained availability. So think about that. And finally, you can do a reliability and availability and maintainability study. And typically in the design, it's used to confirm inherent availability. It's very rarely used as a design tool to optimize the design in terms of availability. So stop using it as a static tool to just confirm the design and use it as the dynamic optimization tool that it actually can be. Within Rely, of course, we thought about it. Our layout is really designed for optimal inspection. Safety critical devices are accessible. Maintenance that needs to be done frequently is accessible, both for people and for the tooling. And it can be done online without an impact on the availability. We have our 20 megawatt blocks that are replicable. And there we really looked at the instrumentation of the valves to make sure that the number of spare parts we have for our systems is minimized and we don't have very large stocks and very large square meterage for that. Our layout is built around the John Cockerell 5 megawatt electrolyzers. And of course, we looked at how to replace those electrolyzers easy with a minimal impact on availability as well. So, I explained how to design for maintainability. Now you have to do, how am I going to de-risk the project? And that's where the third part of the Romans came in. Get a contractor with skin in the games that gives the right, let's say, performance guarantees for your project, whether it's availability, degradation, stack lifetime, whatever drives your system. You can design the performance for tomorrow, but if you don't have a good contract behind it to de-risk, you basically have no certainty today. The one message that I give there is that LTSAs are very difficult to compare. Two LTSAs with the same price might have a very different scope in terms of maintenance, whether it's preventive and corrective, whether that's included, yes or no. The guarantees might be entirely different. Two availability guarantees of 96% might mean completely different things, because one includes corrective maintenance and the other one excludes it. So try to levelize all the LTSAs that you get and make sure that you compare apples to apples, because very rarely that's done today. Within Rely, we really understand that LTSAs are essential for your system. So we took an approach across 3 axes to optimize it. We secure it at the plant level, so you don't have fragmented LTSAs for different equipment. It's just for the entire invariant scope of the plant that we actually give guarantees. We maximize the availability because we're basically involved in the design and we did the reliability, availability, and maintainability studies. And we empowered the operations to involve them in certain maintenances to make sure that our scope is as low as possible and the price as well. Of course, the Romans wanted to have their contractors to have skin in the game, and that's what we do as well. We give guarantees on availability, on degradation, and on the stack lifetime with sufficient liabilities so that we're always incentivized to optimize the performance of the plants that we build over the long term of the project. So we design for performance tomorrow, but we give the certainty today in our LTSA systems, which is called the essential offer. So in summary, if I can, let's say, repeat the main messages for today, for me, it's not CapEx that's king, it's availability that's king. Really understand what you're optimizing for and how to optimize best for your project. Performance is green because electricity price is still very important in Western Europe, and CapEx comes in a distant third, and we're not really talking about OpEx at all. Lesson number 2, understand that the contractor performing the design knows what he's doing, that he understands the sensitivities in percentages, but also in euros, and use RAMs not as a static tool that it is today, but as a design driving tool. And finally, levelize your LTSAs so that you know that you're actually comparing apples to apples. And then a small, let's say, image to keep you a little bit engaged. If you see a chateau like this in France for a small price of 327,000 euros, you know that the problem is not in the CapEx. The problem is somewhere else. Whether it's a very impractical design with a layout where you have to go from room to go somewhere, whether it is in the upkeep, whether that's the maintenance of the gardens, whether it's the roofing, or whether it's the plumbing, if you buy this, you might lose money on day one the moment you go into commercial operation. So really think about that. So thank you for your attention, and have a nice day.